Hello, with our hydraulics class here at the University of Akron, Professor Wise will be teaching you guys about centrifugal pumps. My name is Tyler Stinson.
My name is Tremaine Thompson.
And my name is Josh Tompkins. During this video presentation, we're going to describe how centrifugal pumps work, how they are applied, explain the importance of the pumps and applications, how the energy is used with Bernoulli's equation, and demonstrate through animations.
First, we'll be starting off with what is a centrifugal pump. A centrifugal pump is a machine that uses rotation to impart velocity to a liquid and then converts that velocity into flow. So some of the common uses for centrifugal pumps can be found in oil and energy industries, agricultural and mechanical industries, pharmaceutical industries, and chemical industries. Now let's talk about how centrifugal pumps work. Bladed impellers are used with a radial outlet to transfer rotational mechanical energy to the fluid, primarily by increasing the fluid kinetic energy, which is angular momentum, and increasing potential energy, which is static pressure. Kinetic energy is then converted into usable pressure energy in the discharge collector. Now let's take a look at our illustration that we have here on the right. As you can see, we have water collecting here, and we have our centrifugal pump right here. Now, as we follow the arrows here, we can see that it goes and it uses centrifugal force to loop around and shoot out of the delivery pipe. I'll have Tyler here explain a little bit more about that centrifugal force.
All right, so to trace it back a little bit, typically a lot of people get mixed up between centripetal force and centrifugal force. So in a system rotating around the axis, such as this, centripetal force is the equal opposite force of centrifugal, which is the force going towards the point of rotation or the axis. But centrifugal force is opposite of that, which causes an object to be thrown away from the point of rotation, similar to how you fall towards a door when making a turn in your car. A perfect example would be here on the next slide, would be this here. These guys propelling the merry-go-round with the motorcycle, increasing the speed, causing a guy to be thrown away from the center of the circle by centrifugal force. And this is a prime example of how centrifugal force works within the system. All right, a few demonstrations we have and models show exactly how the centrifugal pump works. The water being sucked from the water supply or tank is the head inlet, which we'll then describe later on in Bernoulli's equation. Once the water is being propelled around through the impeller blades with increased velocity, low pressure, which maximizes velocity, which then throws water out, displaces water throughout the system. This also describes the velocity scale, how the greater velocity is on the outer edges of the impeller blades going around through the centrifugal pump, which then exits the system, just as I said before. So within the increased velocity system, there's also a low pressure, which we'll also then explain through Bernoulli's equation later on in the slide. So another figure we have showing the centrifugal pump. So within the centrifugal pump, the impeller will be completely immersed in water, lessening the friction, little to no friction along the drive shaft rotating the impeller plate. And then through these blades is where the water holds and catches as being tossed around, then exiting the shaft, the discharge shaft. And on the cross section here on the right, it shows how the shaft gets slightly wider to have a greater head discharge or head outlet of the system, which would then just increase the amount of energy exiting the system.
There are a few different types of centrifugal pumps. There's a single stage, which is a pump that has a single impeller designed for low head production applications. It's a simple and easy design. It's easy maintenance. It's ideal for large flow rates and low pressure installations. And then you have the two stage, which is operating with two impellers for medium grade head use. They ensure more reliable, high efficiency process and lower operating costs. And then you have the multi-stage centrifugal pump, which high head service applications with 3 or more impeller blades. The impellers may be mounted on the same shaft or on different shafts. For higher pressures at the outlet, impellers can be connected in the series. For a higher flow output, you would connect the impellers in parallel. And then a common application for a multi-stage centrifugal pump is a boiler feed water pump. This is a picture here of a single stage, which you can see right here is just the single impeller. There's only one. This is a two stage. Right here you have your two impellers. And then this is a multi-stage. This one has 4 impellers, but see here they are all in the same series.
So here with Bernoulli's equation, this is the main principle of how the system of a centrifugal pump works. So first, with the Z, that is the height or the distance from which the pump operates from the head. Then you have P, which is the first pressure. And here the Greek symbol gamma represents unit weight of the liquid. Usually centrifugal pumps are transporting low viscous liquids such as water, oil, and gas. Also then velocity, there will be a high velocity and a low pressure with the system. With the increased flow velocity of the impellers will lower the pressure. And G represents gravity. Depending on how far the head is, head inlet to the head outlet of the system will change depending on that. So typically from the head inlet to the head outlet, the pumps are pretty much in line with the system. So the head or total energy shouldn't be too much affected by the height or distance. So typically within this system, water is just pretty much being transported. So the head in will equal the head out plus any head loss. Considering that there's little to no friction within the system, there should not be, well, I shouldn't say any, but it'll be a low amount of head loss within the system. So in theory, the head in and the head out should equal one another.
In conclusion, there are both advantages and disadvantages of centrifugal pumps. A couple disadvantages are low flow can lead to overheating of the pump. And another one is if liquids with ferrous particles are pumped out, then corrosion can occur. Some advantages are they produce less friction. The pumps do not have drive seals, so that lessens the risk of leakage. And the liquid cannot possibly leak into the motor because it is completely separated from the pump body.
So centrifugal pumps are one of the more popular systems when it comes to hydraulic mechanical applications or transferring of such liquids. One reason being the efficiency of the pump, low maintenance, and just how they overall work.
And lastly, every centrifugal pump includes an impeller. The impeller is an hydraulic component that rotates to impart velocity to the pumped liquid. And also every centrifugal pump includes a casing. The casing is this hydraulic component that captures the velocity imparted by the impeller and directs the pump liquid to the pump discharge point. Thank you for watching our video.
Peace out.